Looks like we're live. Now, it's been a long time since I've done a live stream, so I want to make sure that my camera still works, my microphone still works. Let me refresh the YouTube that I'm looking at just to see, I guess, if audio comes
Looks like
in.
we're live.
Awesome. Perfect. That's awesome. Okay. So tomorrow, Craig McNeil has booked 3 hours of my time. So that's going to be a very exciting discussion we're going to have. It's going to be from 3:30 to 6:30 UTC -6. I'm in Central Time. Now, the major improvement is my lighting. I used to have just this dark, depressing room, but now we have proper lighting. So that's awesome. Now, I really don't know what to expect tomorrow, but I just want to go over my notes, make sure I still feel comfortable talking to a camera, having people ask questions in the chat. But as you know, I have a very unique understanding of flat Earth, and I'm one of the higher ranking, you could say, senior flat Earth researchers. I don't tend to just deny stuff, I tend to understand how it works. And you can look in the description of this live stream to see the notes that I plan to discuss. The first one is clarifying the differences between the flat heliocentric model, the flat geocentric model, the globe geocentric model, and the globe heliocentric model. For example, you can have a flat Earth still in a heliocentric orbit. So it's important to understand that there's really 4 different types of conceptual ideas that we want to be discussing, and it's important not to let it get strawmanned. For example, a lot of people will present flat Earth still in the heliocentric model, and that is not correct. I just want to have a sip of my drink. This is Sprite and grenadine. I haven't drank alcohol for several months now. Haven't smoked weed for a few weeks, and I've been exercising every day, so arguably I'm going to be at a peak cognitive performance for this debate, which will be nice. Now, the second note, I strongly believe that the flat Earth model both requires and predicts a 24-hour sun, and it's very easy to calculate where that will actually be. We have a celestial declination, which is a sky coordinate of where something is in, you could say, on the firmament, and then we have a 24-hour visibility formula. Let me pull that up, see how my screen sharing still works. So when we're talking about celestial declination, that's the zenith location, the ground position of something. And it's not debatable because we know where these celestial objects are. You can go outside in your house and look where the sun is. For example, in December, when the final experiment took place, this was roughly the calculation that I did to determine that the celestial declination of the sun is -23 degrees. And everyone agrees on this, whether you believe in a flat Earth or globe, we know the location of the sun. What you can do after that is then apply a 24-hour visibility formula. And these are just my rough numbers here. It'll be showing past 67 degrees of latitude, north or south. The exact number is 66.56. But I'm just trying to give you guys a proof of concept so you can understand how we know that the flat Earth model not only requires, but also predicts where you'll have to go to be able to see a 24-hour sun. So we know that anywhere south past 67 degrees of south latitude, you're going to have a 24-hour sun. And consequently in the north as well, it's that same thing because we know where the sun goes. The farthest north it goes is about 23 degrees. That's the Tropic of Cancer. And then the farthest south, again, -23 degrees. That's the Tropic of Capricorn. The third is, now this upsets a lot of people, but the flat Earth model does require and predict the force of gravity under the infinite plane model. This is very important to understand. The major reason why people would, I guess, dismiss gravity is possibly due to them believing that Earth is a floating disk in space. And they would be right in that regards. If Earth is a floating disk in space, gravitational vectors point towards the center of mass and nothing works. You know, you drop something down, but instead of it going down, it goes to the side. And we don't observe that. You can drop something down and it always goes straight down. That's how we know Earth is an infinite plane. You can look at the thumbnail of this live stream to see the model that I believe is most accurate. It's the Firmament Tracker's Flat Earth App model. But we have Earth, which is finite. To clarify, Earth itself is a disk, but it rests upon an infinite plane. Correct, yes. Now, the way we quantify this is using something called Gauss's Law of Gravity. Now, it's derived from Newton's law, the mass attracting mass law, so globers can't deny this. And it's a real applicable thing that applies to an infinite plane. And when you have an infinite plane, the symmetrical spread of mass results in the perpendicular gravitational vectors. Now, I'm going to go into something else after of why we need gravity. But first, I just want to show you that it works, and there's no reason to deny this. Now, with Gauss's law of gravity, there is something interesting. You get a constant gravitational acceleration, so 9.8 everywhere. And that's not exactly true. For example, the higher up you would go above our flat Earth, the weaker the gravitational field actually becomes. So we need to modify Gauss's law a little bit so that instead of a constant mass, we have a gradient mass density. That's the formula right above me. Now, the exact numbers don't matter. I'm just trying to show you the proof of concept. For example, I don't know how thick Earth actually is. I don't know the actual density. But in terms of does gravity work on flat Earth? Absolutely. But why does flat Earth predict it? A lot of people wonder why I stress so much about teaching this, and there's a very good reason for that. You can get, let's say, a hydrogen balloon, and let's actually focus up on the hydrogen balloon to make this a little more clear. So we have a hydrogen balloon, and you can let go of it, and it's going to go straight up. But how fast is it going to go straight up? This is where it becomes an issue for people who choose to deny gravity. For example, there's the buoyant force, which goes up. Everyone agrees on that. But if you don't acknowledge that there's also a downward force, and to clarify, I don't care what you want to call this force. You can believe in the electrostatic theory of gravity if you want. The theories that attempt to explain the force have nothing to do with the force itself. So to make that very clear, I choose to believe in Gauss's law of gravity. You don't have to. If you believe in the electrostatic theory of gravity, that's perfect, as long as you acknowledge there is a downward force. And we call it F of G just so that other mathematicians and other scientists understand what we're talking about. I understand still that the term gravity itself is, you could say, an uncomfortable word to discuss in the flat Earth communities, but that doesn't matter as long as you're able to get a downward force. And the reason why that matters is because the net force, the difference between the buoyant force and the gravitational force, the downward force, the difference between the up and down force is how we determine how fast something's going to go up or down. So with the hydrogen balloon example, it's a very basic example that I think most people can understand. You have a balloon, you let it go up, even helium, you can use anything. I just chose to use hydrogen for this example. But you know, you go to like the party store, get a balloon, fill it with helium, let it go up. Same thing with hydrogen, it's going to go up. And you can measure that in real life. You get an accelerometer, you point it at the balloon, you let it go, and you're going to get some number. It might be 100 meters per second, it might be 150 meters per second, but you have a value that you know it's going to go up. Now, here's the thing. So for example, in this one, we have a downward force of 3.5 newtons. If you ignore that and only use the upwards buoyant force, so it's 51 newtons of upward force. If you do your basic math, force equals mass times acceleration, your acceleration is going to be a lot faster than what we would actually observe in real life. And let me just write that down so I can quickly do it. F equals ma, that means A equals force divided by mass. The mass in this case would be you would times your density by your volume. So see this hydrogen balloon, it has a density of 0.089, it's 0.08 in the diagram, but on the right the actual density is 0.089. You multiply that by the volume and you get the mass. So let me just show you guys, because this is very easy stuff that I think should be taught more, but a lot of people either are afraid to, or they're just grifters, like Jaron. Jaron is one of the well-known people who deny gravity and spread a lot of lies within the flat earth community, and that's not good. We don't want that. So you end up with 0.35 kilograms. Awesome. So we know the mass, no matter what, is 0.35 kilograms. And then acceleration is force divided by this mass. So I'm going to write two different accelerations down just so I can help you guys do this. So if we pretend gravity doesn't exist and we want to only use buoyancy, the upward force, well, that's going to be 51 newtons divided by 0.35 kilograms. But if we subtract the downward gravitational force from this buoyant force, we get around 47 newtons. It would actually be 51 subtract 3.5, 47.5. Let's use just exact numbers to make this more accurate. And then you're going to have two accelerations, and only one of these accelerations is going to match what you actually observe in real life. So let's start with gravity doesn't exist. Well, 51 divided by 0.35, that is 145 meters per second per second. That's the upward acceleration. And then if we acknowledge that there's a downward force and we use the actual net force, the buoyant subtract gravity, well, that's 47.5 newtons divided by the same 0.35, and you get 135 meters per second per second. Well, if you got this far and you're still watching, you're probably able to realize which one is what you actually observe in real life. It's not that hard to figure out that there is definitely a downward force. You can call it whatever you want. You can believe in whatever theories that attempt to explain this force. The electrostatic theory is one that I very used to strongly believe in, but once I found out that Earth being an infinite plane allows us to use Gauss's law of gravity, and it was a lot more quantified, well understood, and globers can't deny it because it's derived from Newton's, I figured why not? I see no issue with Earth being an infinite plane. However, biblical cosmologists may disagree on this, and you're welcome to. There's many theories that attempt to explain this downward force, but the worst thing you can do is say there is no downward force, because then you can't predict stuff. Your model will fail to predict stuff. So I hope I was able to explain what I just said very clearly, and you might want to go back and watch the last 3 minutes over again to clearly understand the exact math we did. You know, force equals mass times acceleration, therefore your acceleration is going to be your force over the mass, and then it's very simple. So in the top right example, we have the buoyant force. The upward force is 51 newtons. Now, newtons is a measurement of force. It has nothing to do with Newton himself. It's just the term. There's SI units in science, and newtons is a measurement of force. The upward buoyant force is 51 newtons. The theoretical downward force is 3.5 newtons. And if we don't use that, we get an acceleration that does not match what happens in real life. So I think that's very important to understand, and that is why I strongly argue that gravity on an infinite plane makes perfect sense, specifically on the flat Earth. For people using electrostatic theory of gravity, you're going to have to argue it a lot more, whereas with Gauss's law, there is no real arguments. If a glober believes in spherical mass attracting mass, then by default they have to believe in this. Now, just to clarify again, I don't drink alcohol, haven't for a few months. This is Sprite and grenadine. And let me just look at this one more, if there's anything I want to mention about this. So I guess the major difference between Newton's law of gravity and Gauss's law of gravity is that Gauss's law of gravity is expressed as an integral, This is a form of calculus, and it lets us deal with infinite quantities. So Earth is an infinite plane using this. That's very important to understand. Now, the fourth point we're going to talk about, the South Celestial Pole. Again, there's no reason to deny this. A lot of people, for whatever reason, do deny it. You have people such as Flatzoid, who lives in South Africa, sees the South Celestial Pole every night, but chooses to deny it. Again, this is where we get into the concept of trolls or grifters, or are they just stupid? I don't know. But again, I'm not here to make friends in the flat earth community. I'm here to tell you what you need to hear, not what you want to hear. And overall, once you take the time to understand this and you don't get triggered, you're going to have a better understanding of how the real world works, how our flat earth actually works. Now, to clarify, the flat earth model requires infinite south celestial poles. The reason why is that longitude is a continuous coordinate system. For example, and I'm using Globe software on the left to validate this point. You'll often see, I think it was Professor Dave who tried to strawman how it would look on flat Earth, but he also falsified the globe by doing so. With the Southern Cross, it's not going to be in the same orientation no matter where you're looking. It's actually going to be rotated up to 360 degrees, which is actually a stronger argument point for our flat Earth model. You can go to this example, which is in like Argentina, Chile, and then also go to New Zealand. Go on Stellarium, look at the Southern Cross. The bottom circled dot is the South Pole, but that other circle dot, it's on the left in the bottom image, and it's a little bit on the bottom right in the top. That's the Southern Cross. It is not in the same position. Therefore, it's perfectly fine to argue that we do have infinite south celestial poles, and through the concept of dome refraction, let me just see if I have a slide for that. Yeah, through the concept of dome refraction, we only have one physical celestial object. So that could be the sun, it can be the stars, but there is only, for example, with the Southern Cross, there would be 4 major stars that make up that constellation. And those 4 stars are physically on the dome firmament, shining through. That is how we get the refraction, which results in many phenomena such as the 24-hour sun, the infinite south celestial poles. So that's very important to understand. When we look at the firmament, light is refracting from the original point A to point B. So with the south celestial pole, that's nothing you should deny. We have infinite south celestial poles. Now, the next one, number 5. The flat Earth model can predict 8 inches per mile squared under certain wavelengths of light. This is a visual optical illusion only and has nothing to do with the surface itself. But I don't want to believe that everyone who goes high enough and can see a slight curve, they're all just faking it or trying to troll us. I'd much rather believe that there are actual optical illusions that can happen, and there is a 3-hour lecture by a guy, I think he goes by Life is Great. He has a very small YouTube channel, so I copied it over to Rumble just so it wouldn't get taken down. It's a senior level lecture, very good content, and he goes over how with certain wavelengths of light, the flat Earth model absolutely can predict 8 inches per mile squared. So if anyone shows you a photo of a curve, it doesn't necessarily mean it's fake. Now to clarify, photos from deep space showing an entire, yeah, that's all fake. That's not real at all. But I'm talking about someone who has a weather balloon, goes up 150,000 feet, and they claim to see a curve. They might actually be telling the truth. And again, these are senior level topics. This is a 3-hour lecture to understand this, but I strongly encourage you to go through. Number 6. The globe model consists of 2 models, astronomical and geographical. For example, when we're talking about astronomical models, this would be something like VSOP 87. This is a sky model only that has nothing to do with the shape of the Earth, nothing to do with the surface you're living on. When we get into the ground models, this is stuff like WGS 84 that has to do with the shape of the Earth, specifically the oblate spheroid model. As you know, the globe is not perfectly spherical. Let me just see. That's why, like, these are toys and they say not for educational use. They're not actually realistic. You have to have an oblate spheroid to do any real-world stuff in the theoretical globe model. Now, it's important, though, to understand that when we're talking about WGS-84 as a ground model, this has nothing to do with heliocentrism. That is only for the ground. You can have a geocentric globe model using WGS-84. So I stress this because it's important to clarify that there is no single unified quantified heliocentric globe model. They take and mix the best parts from both worlds, and that's fine. You can do it to create a theoretical model, but it's very important to understand the difference between the astronomical models like VSOP 87 that are only for the sky and the ground models such as WGS 84, which have nothing to do with heliocentrism and would work perfectly fine in a spherical geocentric model. And that's a real thing. There's a lot of people who, for whatever reason, believe the Earth is the globe, but they still know that it's the center of our universe and everything revolves around us. And they would use WGS 84. Now, let's talk about longitude and latitude, as longitude and latitude are abstract concepts that have nothing to do with the surface you're standing on. Specifically, it's from something called the graticule. Let me see if I can have a good diagram to explain this. The graticule is simply just made from going outside and looking at, for example, Polaris. I live in Belize. Polaris is 17 degrees from my horizon, therefore my latitude is 17 degrees. Very simple to do, anyone can do this. You can construct the graticule yourself. This is a conceptual model that has nothing to do with the surface. And to stress that, we know that Earth is an oblate spheroid. So a perfectly spherical graticule has to be projected out to an oblate spheroid. There's not a one-to-one relationship to that. And this is where it gets important, because when we talk about projections, we have, for example, the globe model, which uses the oblate spheroid projection, but on flat Earth, we use the North Polar AE projection, the Gleason map, and I believe that is the most realistic representation of Earth. However, it's important to understand that there's nothing wrong inherently with projecting it out. The globe model is a projection of the graticule. The perfectly spherical graticule is projected out to an oblate spheroid, just like how we on flat Earth project that same graticule to the North Polar AE. That's very important to understand because people often claim that flat Earth models are globe projections, but that's not true. The globe is also a projection. And there's many projections. For example, the Awake Souls, they run a large YouTube channel. They argue that the oblique Mercator projection is what we actually live on. And again, that itself is a valid hypothesis. Personally, I don't believe it. I believe the Gleason map, the North Polar AE, is definitely what we live on. Let's talk about time zones. Time zones is something that you'll see even flat earthers get confused about as well. You'll see them show like a picture of the Gleason map with straight lines on it saying time zones make more sense on flat Earth. But that's not true. Time zones are not perfectly straight lines of latitude. And if, for example, if you live in the United States, you can look at your local time zone map, pull it up on Google right now while I'm talking to you, and you'll see like zigzags and box curves going through the time zones along the line of latitude. You'll see the line of latitude, which is perfectly straight, and you'll see the actual time zone curving in and out. Some cities have their own, and it's entirely man-made. So I want to stress that for two reasons. Don't pretend that time zones are any different on flat Earth. The exact same zigzags and lines happen on flat Earth because it's a man-made concept. And then don't let junior level flat earthers mislead you by showing you like the meme that has the confusing globe time zones and then the flat Earth ones that are somehow different. Time zones are all the same, they're man-made concepts and have nothing to do with the shape of Earth. Number 9. Globers like to lie and claim that I stole Walter Bislin's model. Is that this one here? Yeah, so Walter Bislin made a model in 2017. It is good, but it's only for the sun and moon. It doesn't do what the model I made does do. My model is multiple observers, which is something that even Globe software can't do. And my model has the sun, moon, location search features. They're entirely different. So they like to lie, or I don't really know, but there is a claim that the firmament tracker's model is stolen from Walter Bislin, and there might be confused on the little domes, but if so, that would be as ridiculous as saying Stellarium copied Sky Safari, just because they use what's called an equatorial grid. Every astronomical model uses these grids. For example, even the Globe model as well will have two little... So Globe software cannot support multiple observers. That's partly because Globe developers just aren't as experienced as I am. I'm a very skilled software developer, so I made like the only astronomical model that supports multiple observers. But there is one model. It's the Dr. Marsh model. Let me just find it, because I would like to show it if I can. Yeah, right here. So Dr. Marsh made a model that has one little observer on it. He can go into third person just like flat earth models can, but he was only able to get one observer, and only for the sun. So this is the model that Jaron likes to shill around saying the Globe has a model. It doesn't really, though. It's a sun model. You can't tell me about the moon, you can't tell me about the planets. That is why flat earth models are still at a more advanced level than Globe models are. Specifically multiple observers, but even just the ability to have even the sun, moon, planets all in a single model. That's why the firmament trackers is such a threat to Globe believers, and that's why they like to lie and say it's a Walter Bislin model. But you can download the Walter Bislin model for free. It's on Android, and you can test it out and see how it's completely different. Question in the comments, what level are you? I'm a senior flat earth researcher, so on the higher end. I have about, you could say, 5 years of studying, and then the last 2 years I started actually teaching this in a professional setting, giving lectures, creating free content, free apps. So a very simple example, a junior level flat earther will say there's no 24-hour sun, gravity doesn't exist, I don't know where the south celestial pole is, flat earth has no model, we make no claims. Yeah, like the Nathan Oakley group, that's an example of junior flat earth researchers. Senior level flat earthers acknowledge that there's a 24-hour sun, that there's infinite south celestial poles, that the flat earth model requires gravity. We don't go nah-huh, we explain how it actually works on flat earth. The 10th point goes into some of my personal favorite evidence for flat earth. Now, it's important to clarify that science can't really prove anything definitively. It can only falsify stuff, and any new evidence from both sides, Globe and mine, can always disprove the hypothesis. So having that said, though, there are 4 pieces of evidence, not proof, that I choose to make me really strongly believe that the flat earth model is more realistic than the Globe model. Let me just get a drink of my Shirley Temple. Oh, that's good. Let me put the lime in. Oh. So the first is that the sun and moon appear in the same size. If you want to believe in the Globe model, then you also have to believe that just by chance, for some reason, the sun is 400 times farther away, while the moon just happens to be 400 times smaller, so it gives the illusion that they're the same size. To me, that's ridiculous, especially when you get into the concept of Big Bang cosmology, how it all just happened by chance. It's not happening by chance. Whereas for flat Earth, we know that we operate under a creation framework. I don't really care what God created it. All we know scientifically, what we can prove, is that we are created. A very basic example is that Big Bangs don't form dome firmaments. Because we live under a dome, we know that we are created. Whether it's simulation theory, whether it's Islam, Hindu, who knows? Personally, biblical cosmology is a very good starting point, and there's nothing wrong with that at all. So that's number one, the sun and the moon appearing the same size. For me, that points strongly towards the flat Earth model being the most accurate. Number two is the sun's ground position. As I talked about earlier, the farthest north and the farthest south that the sun travels is 23 degrees. That would be at the Tropic of Cancer, and in the south, it's the Tropic of Capricorn. Now, this is true no matter what. Globers agree with this. Everyone agrees with this. It's how celestial navigation works. It's called the ground position, and it's not debatable. And you can go outside and measure this. Let me just go to that slide just so you can see what I was talking about. This is also celestial declination. So, for example, in December, the celestial declination of the sun was negative 23 degrees. That also means latitude. So there's a one-to-one relationship between the sky coordinate declination and the ground coordinate latitude. This is another reason why I said earlier, if I go outside and see Polaris 17 degrees from my horizon, well, that means my latitude is also 17 degrees. This happens because the Earth is flat. It's a perfect one-to-one ratio. But going to celestial declination, this is also arguably the ground position at the zenith. So we see that the farthest south the sun goes is negative 23 degrees, and the farthest north, 23 degrees. Why does this matter? Specifically, if you do a more precise calculation than what I just did, you get 23.44 degrees. What is that? Well, that's the globe's tilt. And it's kind of interesting because if you take the flat Earth model and wrap it around a ball, you have to add an additional tilt, which just so happens to be this exact ground position. So the globe requires an additional step to make it work. You can't have a globe model, or you can't wrap flat Earth around, however you want to describe it, without adding that tilt in. And that tilt is the farthest north and farthest south that the sun travels. This is the ground position that you yourself can determine by going outside, looking where your sun is right now, and doing the celestial declination calculation that I told you. That's why when you understand first principle concepts in observer-centric cosmology, you realize all the additional requirements that the globe model has to have. They took the ground position of the sun and added that to the tilt of the globe. It's the exact same value, and to me that seems like they're just reverse engineering the real life flat Earth model to make it work on a globe. You could also argue it's just coincidence, but then again, how many coincidences until the globe model is just not realistic and the flat Earth model is? The third piece of evidence that I like to believe in for evidence of flat Earth is that when you look at the moon, there's no spherical rotation. It rotates like a flat disc, so it just go like this. You never see a dark side of it, you never see a different side. You can argue that it's concave or convex at best, because sometimes little sides of it will show, but the point is, we don't see a ball rotating, and that matches the flat Earth model and the cosmology that we would expect if celestial objects are on the dome firmament. So again, I believe that all celestial objects are on the dome firmament, and I do believe the sun is flat as well. Same with the moon. That's why it rotates like that flat disk. That's why sunspots rotate around as well. And because the dome is a parabolic structure, you can argue that it is going to be convex or concave instead of just flat. But again, this points more towards the flat Earth model being more accurate than the globe model being more accurate. And then the fourth point of evidence that I like to believe in that strongly points towards, or you could say strongly falsifies the globe model, is that if space was real, they wouldn't always have to be faking it. And this goes way back to the first moon landings, to Elon Musk when he put that red Tesla Roadster in orbit and it was obviously fake, yet everyone thought it was real, to even the recent Katy Perry trip. It's obviously fake, and I can't understand why they would have to fake space if it was possible to just go there. So those are 4 pieces of evidence that point me towards believing in the flat Earth model rather than believing in the globe model. Now, point 11 is when we get into positive proof. Remember how I said science can only falsify? And it's true. We can very easily falsify the globe model, but because our current scientific abilities are so limited, we can't actually go to space ourselves. Whether that's intentional or unintentional is for debate, but the objective fact is that only the government and elites, celebrities, are the ones able to go to space, and we have to rely on their claims. The issue for me would be that if it was possible for people like me, people like you guys in the comments, if we could go to space and finally get a consensus, not just one person, but a whole bunch of people being able to go to space, coming back with their own photos and stuff, yeah, that would be positive proof. If everyone went to space, regular people like me and you, and they said it's a globe, well, I'm probably going to strongly believe it's a globe or try to understand how that happens. Maybe the spherical geocentric model is true. But consequently, if everyone went to space and they kept on coming back with flat images and we all found it's flat, well then that's positive proof for flat Earth. The issue is that we just can't do that yet, and that's why this debate even exists, because there's strong arguments from both sides, and it really comes down to kind of getting over your initial cognitive dissonance. So based on those 4 past pieces of evidence that I gave, it makes sense to me that Earth most likely is flat. But can I claim that with 100% certainty? Not really until I go to space. For point 12, I believe the final experiment was real. All claims that people are making saying it's faked can easily be explained, and they all have. In my opinion, the only people that are still claiming it's fake are people whose ego was too high to admit they're wrong. And it's important to understand that a lot of flat earthers, both at the senior and junior level, chose to deny that there'd be a 24-hour sun. I have no clue why they would do that. It makes no sense, and it could also not be ego. It could be their understanding of science just wasn't at the high enough level. Now, for me, I made sure to publish it in my book, the Flat Earth Science textbook. So I put it on page 130. This was released in September, and I made sure to do it so that people can't say, oh, you're just lying, you're changing your mind, whatever. But we know that there would be a 24-hour sun in Union Glacier, and I put it in my hardcover book that hundreds of people have, so I can't go back and change my mind because I believe in my science. The scientific method is how we know the Earth is flat. It's how we know everything, and that's why I knew there'd be a 24-hour sun. So for people who say it's fake, like people like Jaron, who's a well-known grifter, he used to argue that there's no 24-hour sun. That's called grifting, or in his case, he might just not be smart enough to understand the science. That might be why he left Flat Earth. There's no way to know, but the bottom line of what I argue and what I say is that there's no valid reason to deny the final experiment, and there's no valid reason to pretend there's no 24-hour sun when it works perfectly fine on the Flat Earth model. Like, it makes perfect sense. If the celestial declination of the sun is negative 23 degrees, and we know that perspective rises and falls by about 1 degree every 69 miles, you can easily do the calculations to figure out that, yeah, there's definitely going to be a 24-hour sun. It shouldn't surprise you. It's basic math. Now, the mechanism for how it works can be debated. People like me, people like Joe Hanvey, we tend to believe that, let me see, where is the image I want to show? Yeah, this one here. So tons of people, even Flat Earth Dave, Living Water, a lot of us have studied the concept of dome refraction, what happens when light shines through a firmament. That's very important to understand. There's no reflection, it's refraction, and it's a parabolic one. And there's nothing that should have surprised anyone with that regards. Oh, it's raining now here in my house. I hope it's not going to give too much background noise, and I hope the audio and stream quality doesn't cut out, but we're almost done here anyway. So then the final point, 13, a lot of people just say, oh, you're grifting, oh, you're grifting. An example of grifting would be the recent etheric summit that Jaron promoted. He was trying to sell people $65 tickets to watch a Zoom. That's grifting. Now, for me, I have a $50 hardcover textbook, and it's free shipping. So this alone is better than Jaron's stupid Zoom summit for $65. But you can get the ebook for $10, and then the app. I sell this app for $12, and it supports multiple observers. That is something that Globe software can't even do. So you're getting stuff for real value. So I argue that I'm not grifting. And not only that, but to mention that I have a complex corporate structure that I operate under. I work for the Journal of Geocentric Cosmology. That's my employer. And it's a very complex corporate structure. We have Apple developer licenses to pay for, Android developer licenses to pay for. We have multiple websites. Like, for example, you guys might not know this, but Apple charges us $100 a year just to make free apps for you guys. So I argue I'm not grifting. And you can even get free apps, and I have tons of free products. So that would be the 13th point that I imagine might get brought up in the upcoming debate. And for anyone who just joined in randomly, the whole point I'm doing this is that I have a debate tomorrow with Craig McNeil from FTFE, Fight the Flat Earth. He's paid for 3 hours of my time. So just like with Will Duffy, I'm going to be very clear-headed, very sharp focus. I don't drink alcohol. I don't smoke weed. I exercise every day. So lets my cognitive performance be at that optimal level. And again, I'm not the typical flat earther who chooses to just deny everything. I have an explanation for how everything works on flat earth. And 3 hours is interesting. So I'm expecting to also have people like MC Toon, Globy McGlobeface appear, and it should be quite interesting. But I just wanted to test my lighting. For example, back in the day, this is how I used to look. I would actually do this, and that's with my actual lights on as well. But now I have proper lighting, so it looks good. My microphone still seems to be fine. Webcam looks fine. It's raining now. I live out in the jungle on the Flat Earth University Belize campus in Central America. So on our roof, there's like point-to-point radio to get Wi-Fi. It seems fine right now. That's my only concern, is that it might go out during the debate, but it hasn't yet. So I thank you guys all for tuning in. This was an hour, actually it was only 45 minutes going over everything. So yeah, if you guys have any questions, it seems the chat is not too active. That's perfectly fine. But the points that I talked about will be in the description of this live stream as well. So you can see the 13 points that I believe in, that I argue. And I don't know if there's anything else I would need to add. Everything I believe is pretty much there. And almost this time tomorrow, so in about 26 hours, I'll be talking to Craig McNeil, and it should be quite wonderful. So thank you all for tuning in. Watch this from the start again if you're just tuning in now, to go over all the senior level flat earth concepts in a quick way. And I encourage you to test this stuff yourself. So like when I was saying about the South Celestial Pole, pull up Stellarium. Confirm what I'm saying. Don't just believe me. Same thing with here. When I'm saying flat earth predicts gravity, do the calculation yourself. Find out, like I walked you guys through it on the calculator and the paper, but do it yourself. Follow along, and you can see how we know this stuff. And it's fun. It's easy. It's flat earth math is planar trigonometry. There's no spherical trig. It's
very easy to understand. And it's usually just a review of your high school math. We just never got taught proper cosmology in school. So thank you guys. Hope everyone in the flat earth community is staying strong, staying healthy, staying sober, exercising every day, spending time with your family, your pets, your dogs. The most important thing I would say is not letting the harassment from the globe side get to you, especially when you're their superior in every measure.